This is an important topic when we look at what is happening with regards to the COVID pandemic and changes in the brain. For anyone who had been following my work early on, they would have realized that I'd been doing a lot of focus on dementia prior to the COVID pandemic. This was a passion, and this was something that I was interested in, and it was because of personal reasons. My mom had dementia, and I invested almost 12 years into trying to understand the disease. So when COVID hit, I used the same kind of research techniques that helped to solve a lot of the issues around dementia in the context of COVID. And this is how I saw COVID autoimmunity from early 2020. So I'm now doing the full circle because part of the reason why I didn't go back to focusing on that dementia research was that I knew intuitively that the inflammatory process that occurs with COVID is likely to affect the brain as well. And so, therefore, you can't actually resolve the inflammatory process if you don't deal with spike protein autoimmunity. So, this is where I've come from, and the evidence is starting to accumulate. And this is what I'll be sharing with you today. Before I do, just because it is that important with regards to brain fog and this sense of people being perpetually intoxicated, I'm going to put together a presentation just on this within the next few days. Look in the link in the description below for the link if you want to join me, for this is an important topic. Part of this work is understanding what happens with the brain. Now, when it comes to the paper that was being studied, I need to make you aware of a few very simple facts. So, the first thing is that it is about accelerated brain aging during the COVID 19 pandemic. It was just published in June of 2025. And this is an important paper, one of the few ones using the UK Biobank. And one of the problems that I identified very early on is that I looked at it and I thought, as I searched through it, as I do, there was absolutely no mention of vaccination, nothing at all. And so whenever I see that, that's always a red flag because literally they went through almost every aspect of the person's health, socioeconomic, their health status, their all kinds of stuff related to the health of the cohort, and they did not include vaccination status. Now, the options are they didn't realize it was relevant. Now, I really can't believe that. Two, they didn't think that it was important, which is even worse. Or maybe they didn't have access to the vaccination status. And so therefore they couldn't talk about it. And that's one of the reasons that could be said. Makes sense. But I'm not letting it go there. As I said, I will make sure that these points don't get away. And so, of course, I went to look at a paper talking about the information in the UK Biobank questionnaire, the UK Biobank, and they looked at a questionnaire data here. So this is a research paper here from 2024. And as I go through it, what I want to just zone in on so that you understand right here, COVID-19 vaccination. To further assess the population characteristics, the UK Biobank asked their population if they had received a COVID vaccination. So they asked them, this is from early in 2023, and you can see here as we go down, the section, I'm going to show you the section where it talks in detail about the vaccination status. Here we go. Of the 200,000 people who who provided vaccination status, 117,936 had at least received one vaccination. And this was earlier on in the pandemic. And so, what we are looking at when we talk, this is almost 96% of the cohort. So, the reason why I'm highlighting that is that when they're doing a study in terms of the UK Biobank, it is very important to know that the very high probability is that maybe 90% or even more of this cohort has been vaccinated. And so, what we're studying is not just the impact of COVID on the population, it is the impact of COVID on the vaccinated population. I differentiate that because I understand about spike protein immune responses. It's not the same. And just so that you're aware, if somebody had mild COVID and they were unvaccinated, usually it means that the infection is confined to their upper airway and probably only a few virus particles get into their bloodstream. What we knew happened in terms of the vaccinated cohort is that they could have significant impact of virus in their bloodstream with only mild symptoms. It is not the same. And so this is a very, very important point when I'm speaking about it. And this is why I've highlighted that this is critical in terms of the interpretation. And so what I'm doing here is analyzing it from that perspective. So let's go back to the paper. Accelerated brain aging during the COVID pandemic. They left it off here in primarily the vaccinated cohort. That's essentially what the paper should say. And what they were doing, they were looking at a cohort of about 15,000 healthy participants and an independent cohort of 996 healthy participants, almost 1,000. And when they looked at the scans, their finding revealed that even with initially matched brain age gaps and matched for range of health markers, the pandemic in the vaccinated significantly accelerates brain aging. So this is important. And accelerated brain aging correlates with reduced cognitive performance only in COVID infected participants. Now, that's what they have interpreted, but I'm going to show you that I don't think it's necessarily as straightforward as that. Just so you understand the breakdown as to what they did, they looked at this cohort, the training cohort. So they trained their analysis at looking at the study before the pandemic, people who had a first scan and were healthy and had a repeat scan. So they had a scan in a relatively fixed period of time. And so they then compared it with before the pandemic, before and after. Then they looked at in the pandemic people who didn't have known COVID infection and those who did. And that's what they were comparing, looking at MRI scans to see if there were any changes, as well as the fact that they did cognitive assessments on them. That means they checked them to see whether or not they were able to do standard tests quite easily. And they looked at it from a number of points. Now, one of the things with brain fog is that not very few people, a lot of people will not tell you they've got it. There's a reason, because if they are working, it's going to make them appear that maybe they could be making mistakes because they have cognitive issues. And so they don't want to talk about it. Even in the family, if they are having memory issues, they're having processing issues, very often a lot of people will hide this information because in the back of their mind, they're worried that, goodness, is this early onset dementia or something? And so they don't talk about it. So one of the things about this presentation, it allows people to look at the science, understand what is happening, and potentially find solutions if they understand it without needing to talk about it, because it does have an impact on the health of their perceived health. And what I have been looking for a long time is, as I said, the COVID storm principle. So this is where you have a population who has been vaccine immune primed. That's on the right. That's the B bottle, with recurring COVID infections. And the two together make the epoxy. That's what I call the COVID storm. That I think is absolutely critical for us to understand. And this is what I am saying is occurring at the moment, primarily in the vaccinated cohort. And this is what the data, I would presume, is showing from this. So let's look at a little bit here with regards to gray and white matter. And I'll be presenting more details on this at the brain fog and perpetual. Let me just show you here. If you're interested, make sure you join me with regards to this. The link is in the description. But let's go back to a few slides that I've put together just to show you the principles with regards to the brain and what they were looking for in the scans. So when you look at this here, this is just a brain, a cross section of the brain. This is the head, the brain sitting in here, the cerebellum at the bottom, brain stem going down to the spinal cord. This is the cut section of the brain, cut in half. This here is the corpus callosum connecting both hemispheres. This here is the cerebellum. This is the brain stem taking all the fibers down to the limbs and the body, and as well sensory fibers coming up. And this brain is what is affected. But the question is, what is this question about gray and white matter? And this is an important point that I'm highlighting so that you'll understand the science as to what is going on. So when we talk about an MRI, it's a radiological investigation, and it gives quite good details on the brain. And for the time being, I'll make it simple. Where you see it dark colored, that's the gray matter. That's where most of the processing in the brain occurs. And so you have gray matter nuclei as well inside the brain. This is like this here, as well as on the lobes of the brain. And you also have white matter. And the way to think about it is that the white matter is the cabling lines that connect the gray matter together. So this gray matter may be connected to this gray matter by white matter tracks that help the brain to be able to coordinate everything. So when they did the brain MRI, they were looking at changes in the gray matter as well as the white matter. And that's the image I'll be showing you in a second. This is why I was showing you this. And this is another image to give you an idea as to what the white matter would look like inside the brain. So all of the parts that are not connected would be the gray matter. And then you have all these fibers running all through the brain in these tracks, connecting the front to the back to the brainstem to the frontal lobe. And these tracks carry information quickly, and they can also become damaged in the context of the brain. And so what they found in the research is that primarily the part of the brain that was affected the most was the white matter. Remember the connections, the cabling. And when they compared them, and this is the image here, comparing gray matter to white matter. And red means this was the pandemic period with people who had infection. Green means this was the pandemic period with no infection. Okay. And what you can see, and blue was before the pandemic. So this is your baseline. And you can see that if they had no significant COVID, there was just slight increase or decrease in the gray matter area compared to the baseline. But what is important is when you look at the white matter, you can see that this is starting to trend up. And definitely, if they had infection, it trends more significantly. And this is the point I'm making with regards to the fact that this is largely a vaccinated cohort with infection. So even without infection, we are seeing a trend up. And this test, Trail A, was looking at certain cognitive tests. They were doing multiple cognitive tests to see how people performed. And when they looked at Trail B, again, you can see here, the green line represents no infection, but you are still seeing a significant inflection up compared to a mild infection. Similarly here, this is gray matter, this is white matter. This is indicating that we are having problems across the population whether or not they had a mild infection in the context of what appears here to potentially be vaccination status. That's really the call that I'm making. I don't think it's acceptable now for any study to be being done and not including vaccination status, especially one that is as important as this. It is clear from the data with the biobank that they could have had access to this. And I don't believe that they didn't look at this. What they probably found was just inconvenient. And so, therefore, they decided to just focus on the pandemic. That's my presumption. I have no clear evidence that this is the case, but I just cannot believe that they took all of this data and they did not look at what was happening in the context of people's vaccination status. It just makes no sense to me. And when you look at the exclusion criteria that they had, this is it here, final point. You can see here from the full neuroimaging data set, over 42,000 individuals, only participants classified as healthy, no history of chronic disease, no heart disease, diabetes. That means they had all of this information, full list of exclusions. And so almost certainly they would have had vaccination status because it is part of the UK Biobank data. This, in my view, is the significant issue coming up ahead of us. We have a situation where at the moment, a lot of people are probably struggling with these cognitive memory, brain fog issues, and therefore what it means, it's being underestimated, and therefore nothing is being done. I am trying to find solutions for it. So if you want to join me, I will explain why I think this brain fog is primarily brainstem. And this is why I have linked it to perpetual intoxication, because it's very similar based on my research to what would happen if somebody was just a bit tipsy. They're not quite right. They're able to function, but they're not functioning well enough. Question is, if we understand that, can we do something about it? Let's see if we can work together to find solutions. Join me as we continue to dissect this pandemic. Have a great evening.